Welcome, everyone. We will give people about 2 minutes to show up because every Zoom meeting runs a little bit over. Back in the day when we had like physical conference rooms, you had like this transit period from one to the other. And now we don't have that excuse. It's just clicking from one to the other, and it's still hard. All right. Thank you, everyone, for coming. I am really glad to be here to talk about how we can use observability to see the value in our code, to use it for more than production debugging. My name is Jessica Kerr. Online, I'm known as Jessitron, and I work at honeycomb.io. And we're here today to see some observability during development and some observability used to show the value of development. Great. I have the flow today is we're going to go pretty much right into an example. That example is going to be a fun one, and we'll see some observability results. We'll look at some distributed traces, and then we'll find a limitation. And so we'll make a code change, and we'll see the code change in our observability, and then we'll measure the effect of that code change and some other things. And then at the end, so the last 20 minutes or so, I plan to get into code and like exactly how this observability is implemented. So higher level stuff first, but also we have a really interesting example. Now, in Zoom, we're working on being able to chat with everyone. Because we're supposed, it says I should be able to chat to everyone. I do not have the ability. I have hosts and panelists. I can talk to leads Everett Taylor. So I'm working on being able to see everyone's chat. In the meantime, there's also a Q&A function. I would really like, when we get the chat working, hopefully we can all like say hello, say where we are. In the meantime, the Q&A function should send questions to me. So please send questions at any time. I would like to be a little more dynamic. This is a long session, 80 minutes. So let's let it not be all me. Okay. All right. Let's get started. For the example here, the example of observability as the power to understand what our software is doing. Let's pretend that we are on a platform team. We're a platform team supporting a bunch of development teams, and maybe we're a bank or something, because we want our development teams to use AI coding assistants, but we can't just let them run wild. We have to have control over what data gets sent to that AI. So we want to run an internally operated coding agent. For the purposes today, we're connecting that agent to Anthropic. Maybe our bank would have to use some model that they run in Amazon Bedrock or something. We're going to use Anthropic. But what we're going to get out of this immediately is we're going to see the flow of how an AI agent runs. And oh no. I can't see the chat. So I can't unmute people. Oh, yay. Oh, yay. Oh, yay. Chat messages started coming up. Okay, great. Raman, hello. Syed, hello. Sergey, yay. All right. Now we're getting somewhere. Okay, great. Because I need to know how many people have used AI coding agents. Believe it or not, Claude Code only came out in like February. This is recent stuff. Um, and it's very interesting. Oh, great. Okay, Shannon's in Seattle. Yes. Okay, so everybody please say like where in the world you are. I love to hear about the weather in other parts of the world. And also tell me, especially tell me if you have not used an AI coding agent. Because it's easy to make the assumption that everyone does just because they're, some of us have used them very intensely for a couple months. But yeah, so Gail has used Copilot. Yeah, the autocomplete. Oh my gosh. It makes it really painful to code on an airplane now when I don't have that. All right. Anja's in Germany. London, gray sky. That scans. Thank you. Cursor at work, Cursor and Copilot. Good. I use a lot of Claude Code. I also use Augment Code in my IDE. I especially like Augment for larger projects, but Claude Code CLI usually seems the most intelligent. Adalto from Brazil, great. Trevor's using Claude Code and Copilot. Excellent. Okay, well, today we're going to use OpenHands. So OpenHands is an AI agent that is open source. There's a company behind it, All Hands. And OpenHands is, I mean, it's a coding agent. It has a UI where it'll like run VS Code for you in the browser, but it also has a CLI. And today we're going to use the CLI because it's way simpler. And also, I like it better. Stop trying to take up my browser space. Great. Adalto is using Copilot. Okay. LLMs in general, the generative AI, are fun, but all they do is generate text. A coding agent has a different flow. It does more than generate text. It has a bunch of tool calls, agents in general, and we're using ours for coding. But we're going to find out how OpenHands works. All right, I'm going to share the screen. Be this one. All right, it's not time for the trace yet, though. Don't look at that. We want VS Code. Cha. All right, and here I have a command line where I'm going to run OpenHands. And I need to run it on a project, right? So really we're the platform team and the code we care about is the OpenHands code, but we need something to exercise the coding agent on. And OpenHands is complicated enough. I didn't want to complicate it. So here is what we're going to modify. It is the simplest. What did that just do? No VS Code. That was not it. I clicked that. Okay, I'm trying to click this. It is the simplest web page that I could find or create in a few minutes. Come here. All right. There it is. Okay, this is a web page of my favorite things. We have my kid with their tuba and a magic card that I think is really neat. Look, it has 5 colors. And then our cat and all 3 together. Okay. It's not a very exciting web page. That's all right. What could we do to make it more interesting? I'm going to ask OpenHands to do something to this website. Throw me some suggestions in chat on what to do. And in the meantime, I will get the CLI started up. OpenHands CLI. Simple web page is the default project. And oh, come on, y'all. I don't see any suggestions in chat. How can we make this web page more interesting? Something simple that we think the agent can do. Add navigation, images in a carousel. Okay, I got 2 images in a carousel. That sounds great. Yeah, yeah, and some animation. Okay, set up shell aliases. No, open hands. I don't want that. Okay, can you put the images in a carousel with some animations? Great idea. All right, so it gave me a prompt. I typed something and the agent is running. First, it tries to read a directory wrong somehow. Okay, now it's doing some file reads. Oh, it says a nice message. It's exploring the current directory structure. So it starts knowing nothing about the project, and it always reads index. It likes to read styles, and then it starts changing stuff. And that's what it's going to do. Now, I have a couple links to share. If I can figure out how to do this while sharing screen. Resources. Okay, so there's a resources button at the bottom of Zoom. And local weather. Oh, that sounds fun. Commentaries, it would be good at that. Oh, that's interesting. There's no links option in the resources. Okay, um, I'll need some help. I need to chat these links to everyone since that button isn't there in the resources like it was last time I looked. We're gonna look at some traces. Okay, agent is waiting for your input. It looks happy. I've successfully transformed your images into an animated carousel. Let's see what it's doing. Control-Shift-R to reload the styles. And okay, there's my kid with their tuba. Oh, it's moving them automatically. That's pretty good. Odin in a cat cave. Yeah, I think that's an improvement. That's pretty nice. And all three together. Okay, yeah, approve. Okay, so I'm going to exit open hands, which is just Control C, proceed. And then it asks me, I added this. Was it useful? Yes, it was useful. All right, so now it's recorded that information and we can go look at a distributed trace. Okay. I want to run the poll. This is the time for the poll. Where more? I don't see the poll button. Well, we can just talk about this in chat. Oh, there it goes. There's the poll. Okay, great. What is your experience with distributed tracing? Please answer that question so we can get an overview. And in the meantime, we'll follow this link, jessitron.com/Jaeger. Jaeger with an R. There it is. Okay. So jessitron.com, that's my site, /Jaeger. Jaeger is an open source distributed tracing tool. It's JAEGER. And we're going to look at the distributed trace created when we ran open hands in here. Now, Jaeger is free. And this is what it does. When you get there, you should get to this search page, or if you get something weird, you can click on search. And then the service dropdown has 3 options. The interesting one is Open Hands CLI. And then we'll click Find Traces. It shows us a graph. Red usually means error. That's at 9:56. Okay, that's a long time ago. And it was a very slow one. We are over here. Let's click on this one. Open Hands CLI main. It's also right here. So I can click on the dot or I can click here and we can look at a distributed trace. Let's see if the poll results are in. Oh, I don't know how to see the results. I closed the poll box. Oh, there we go. Okay, great. We got some never used it and mildly familiar. And then a few people like it. and one person has bad memories. Great. Perfect. All right. Distributed tracing is the gold standard of observability. It's not what everyone needs, and it's not by no means the only way to have good useful observability. But it is pretty great when you can get it. And at the end, we'll talk more about how you get it. It's easier than it used to be. But a distributed trace it's like a bunch of structured logs, except they're interconnected such that they can be drawn in a graph like this. It represents one externally visible unit of work, usually. In this case, the trace, this main at the top, is representing my whole session in Open Hands. So this started at when I started up the program, when I started the command line, and it ends when I exit. And we can see that the tops, let's click into here, and we'll see that this is basically a structured log, except that it has a couple extra fields. Jaeger doesn't show them super clearly. Let me zoom in a bit, get some bigger letters. But every structured event represented here, every row here, is effectively a structured log with a trace ID, and they all have the same trace ID. It's this up here in the URL. And a span ID, and here's a span ID down here. So the main span ID got this. And then any other number of attributes. So there's some attributes that are consistent for every event emitted by this process. So it's running in my, is it really running in that cluster? It's not. Oh, my collector is probably running. No, I don't know why it has that. That's interesting. That is my Kubernetes cluster. I don't know how it got on there though. But it is in Python. It's using the OpenTelemetry SDK to send this data and this version of it. And then we have the tags. And okay, tags is a Jaeger term. In OpenTelemetry, which is the open source standard libraries that we're using to emit this data. In OpenTelemetry, these are attributes. And this is a bunch of stuff that's specific to this particular event. So we've got some information about it. I put the user on there. That's me. Oh, and I put the choice on there that I said it made my work easier. And some other stuff. Okay. Interesting. Tool names is an empty array. Oh, but MCP tool names. More on that later. Okay. Each row in this distributed trace is called a span. A span represents some unit of work. Like the main is the overall externally visible unit of work represented by this entire trace. But then there's a span for CLI confirm right here. And here, this is where it asked me something. Let's see what it asked me. This is where it asked me to set up shell aliases. And I said, no, skip this step. So that's one span. It has a start time, it has an end time, it has a trace ID. It also has a parent ID, and I can't get Jaeger to show me the parent ID. I don't know where it is, but I can tell that it has a parent ID that is pointing back to this span because it's making a little tree. So we can, with the trace, we take a bunch of effectively structured logs, but they build into this little tree saying that this parent span, come back. Nope. Oh, there we go. I'm trying to shrink the text. There we go. This parent span caused all of these child spans. And then they're ordered by timestamp. One of the things that starts is run session, and then run session becomes a parent span for a bunch of things that it triggered. And that's where it gets interesting. Now, I should mention that I'm talking about distributed traces, and that's like the technical term for this kind of structured events that build into a tree like this. This one's not really distributed. One of the tags on here should be service name. Service name, it might be under process, says what program emitted this particular event. A great part about distributed traces is that they follow a request from service to service. So if you have, if you accept a web request and then your GraphQL server calls into 6 different other services to pick up all the data before it sends it back, the distributed trace will include spans emitted by all those different services, which is fantastic for your like, where the heck is the problem on debugging? In our case, we only have the OpenHand CLI. It's not calling out to anything. MCPs aren't implemented there yet. So it's all one service. And when I say distributed trace, well, it could be more distributed than it is. Great. Now, let's see what's happening in here. Oh yeah. So like go to this link, go to justitron.com/Jaeger and see what you can figure out from this trace. You can follow along. You can click on it. You can click around in here. If you find anything interesting about how the agent works, please, please, please put that in the chat. All right. So meanwhile, a little bit of knowledge of how the software works goes a long way in reading a distributed trace. So when you have distributed tracing, when you have access to that, it's fantastic to sit down with someone who knows the system a little bit and get a tour. In this case, what we can see from here, okay, initialize code act agent. That's nice. I don't care. I'm interested in what we're doing. Aha, agent step. What is OpenHand's doing? And I can tell this part's interesting because it took 6 seconds. Must be interesting. All right, so we have an agent step. Oh, it looks like it took a file read action. No, I'm trying to see the children. It processed some events. Here it's using a jinja2.render. This means it's using a template engine for something. I think that's actually constructing the prompt. Aha. And then we have the light LLM request. Okay, light LLM is a library for calling LLMs. It like abstracts over which model you're using. And this is going to be the interesting bit. What does an agent do? All right, we'll look at the tags. Completion, that's the response. So an LLM receives prompts and returns completions. That's how this works. So this is what it's saying back. I'll help you create a carousel with animations for the images. I did see that in my console pretty soon after we started. And then it wants to do some tool calls. So let's see where those tool calls came from. I want to move down to this prompt part. Can I make this any bigger? Well, I can shrink it. Okay, this gives you an idea of how much we're sending the LLM. All right, so we're sending it some prompt content, some text. You are an OpenHand's agent, a helpful AI assistant that can interact, blah, blah, blah. This is the system prompt. It's hard-coded in the agent. And it tells the LLM how to behave. It gives it a bunch of instructions. Only install individual packages directly. One great thing about observability when LLMs are involved is they're a black box, and like it or not, they're going to stay a black box. I'm not trying to figure them out. But we need to know what went in and what came out, because as developers on this AI agent, we can control this system prompt. So we need to see what's going in and how it's reacting to that. Okay, so there's a system prompt. It's pretty big. And then there's this tiny bit of text that is what I said. Okay, so that's in the prompt 1 content from the user. And then more stuff goes. This looks like more system prompt to me. It's telling it that it's working in simple web page and what it can do. And then Quest model, Claude Sonnet 4.5. That's the one that dropped Tuesday. And here we go. All right, functions description. This is important. This is sent to the LLM as a part of the request, but it's not actually in the prompt. It's a little separate place. It gets fed as text to the LLM eventually. Somehow Anthropic works it in. But here is functions that are available. One function is to execute a bash command. And there's a bunch of instructions on how to do that. And then there's parameters and descriptions of the parameters. Now, all this goes into the LLM. All this gets to be part of its context. There's a description of the next function. Think about something. Apparently, I mean, this is just a tool that's like, it's a tool that doesn't do anything except accept some text and send it back. But it has been shown to be useful for agents. So it does a think. And the other one it has is finish. The finish function signals the completion. Not very exciting. And finally, we have our custom editing tool. And this one is called String Replace Editor. And it can edit files, it can view files. So this when we see it doing file reads, it's using this tool. And it's a custom tool that's part of OpenHands. So like how you give the LLM access to your files matters. All right, so it gets all those things. And let's go back to the top and see what it responded with. Responded with a tool call. It would like to view the directory. Okay, after that, that seems like it was worth 6 seconds. After that, there's these 3 spans all represent that same call to the LLM. Not sure why. But this is all automatic instrumentation that's like coming out of libraries that I installed. And then there's some instrumentation that I created. We'll see some of that at the last bit, like execute file editor. This is actually going to read the files and directories. And I think we get the output. Here's the files and directories up to 2 levels deep. Okay, this is interesting because it said, view this directory. And it gets back like a description of what it's getting. First of all, it didn't say 2 levels deep. It's just that we decided, our tool, our custom editing tool decided that that's what it needed. And so that's what it gets. And then it gets hints on what else to do. I've seen this also in our Honeycomb model context protocol tool, that when you're designing a tool for an LLM, you make it opinionated, you like inject suggestions of what to do next and stuff, especially on errors. Checking the chat, see if anybody else has some commentary about this trace. I don't see anything yet. Okay, so this is the tool call, and then we go back to another agent step, a little shorter, and we could look at what it's doing. It said, now all I want is some tool calls, show me index.html, and so on. All right, no, shrink that. There we go. File editor, agent step. Oh, this one took longer. I wonder what was interesting there. This one, and this one was a think, I think. Tool calls. Nope, it's doing something. It's doing string replace. Okay, it took it a while to decide exactly what to change in index.html and give us all that stuff. All right, it did the things. And after all of those agent steps, oh, this is it waiting for me to do something. Humans are always the slowest. And then we're done. Okay. So this is interesting. It shows us the flow of the steps through the agents. Oh, I forgot to tell y'all that also with me and able to answer questions in the Q&A and chat. And if y'all come up with any good enough questions, we'll have Taylor unmute and answer them, because Taylor Anderson is here with me. He also works at Honeycomb, and he is an engineer on our AI team and is really good at agents. So yeah, say hi, Taylor.
Hey y'all, nice to meet you.
Yay.
The AI team here at Honeycomb, very excited to be here. And thanks for the awesome walkthrough, Jess.
Thanks. Yeah, Taylor did a lunch and learn the other day at Honeycomb for how an AI agent works. Right. Okay. But we're talking about observability, not just agents. I just find them a fascinating subject for observability. But all right, so we can see what's going on in an individual flow. And next, I want to see what's going on. Well, no. Next, I want to make a code change. And I want to talk about what needs to be different when we make a code change. For that, I need to have a reason to make a code change. So it's time to get a reason. Okay. I love these demos. I love AI coding demos because they put the live back into live demo. You do not know what's going to happen. And this one's particularly fun. All right. So say maybe we got some complaints from our development team about hallucinations. And we'll see if we can trigger one of these. I'm going to run the CLI on the web page project again. Man, that takes a while. No, I don't want your dumb shell aliases. And this time, I want to have it add some animal photos to the website. Anybody got a favorite animal?
My
Any
favorite
suggestions?
animal is an otter.
An otter. Okay, great. A quagga. Is that like a quokka?
That is.
Right. Can you add some great animals photos like otters and quaggas? Nope. And a capybara. Okay, let's see what it does with this. Runs, it looks at the project. It's going to look at index.html. It's probably going to look at styles.css. Oh, nope, it didn't even bother. Okay, now it's asking me for confirmation because this is the first time it's used the bash tool. And I'm going to tell it to go ahead. And it's doing a curl, and that's kind of interesting. It's doing a curl for something. Where did it get that URL? I think it made it up. I wonder if that's an otter. Let's find out. Oh, no, it's zebra. I did not. Okay, apparently Claude Sonnet's favorite animal today is a zebra. I did say wonderful animals like. Okay, it's going to get another otter. Oh, it looks like the Unsplash Rails might not be working for. Okay, they return small files. So at least it's sort of checking its work. These things are amazing. Yeah, it's just going to try some random URLs from other places. Okay, maybe it knows about the sea otter. Is that maybe? It's trying to get a capybara, quagga. Oh, I don't even know what a quagga looks like. This is going to be interesting. It looks at them. Okay. It's trying again. It's just flailing. It's totally flailing. Look at this. Oh my gosh. It's like, well, if it's sized like it might possibly be an image, then we'll go with it. Since quaggas are extinct, limited photos available. Great. Yeah. It's trying it. Oh goody. Oh goody. Somebody Taylor got the image. Oh, that's the real otter. That one's nice. Okay. Okay, it's going to update the HTML files and put them in the carousel. Goody, goody. Now it's trying to look at the page. Okay, it's made a summary. Let's find out what it did. This is the best part. Okay, what do we have here? Control Shift R. All right, we've got a tuba. It hasn't messed these up. All three together. That's actually an otter. Amazing. That is not a capybara, but it is an animal. That's actually what is a quagga a zebra? Is that a thing? That's definitely not a zebra. Okay. It did get some animals. One of them was even correct. Yes, exit and no, that was not what we were asking for. Okay. um, it gives us some links. So or we can go back to Jaeger or Honeycomb. I'll let you know. Here's another link for the chat, jessitron.com/honeycomb. You can look at these traces in either place. So we could go back to search in Jaeger and do I need to refresh or something? No, it should be, okay, find traces.
I hope you're enjoying this video, but did you know Lead Dev has a lot more to offer?
When I think about lead dev, I think about bricks and hearts. Bricks are those foundational things that you need to know. And lead dev provides that through webinars, through videos, through cutting edge research. But hearts are the things that you need to glue yourself to the people at work. And lead dev does that through conferences and meetups.
Make sure you check out leaddev.com.
It'll be this one. So we can look at what it's doing in here. You can see the tools. Here's execute file editor. I would like to get more details on what it's doing in these, like especially like what shell command it's calling. That's fun to look at. And that's in here. It's in this app.command field. But I can't like turn that field on in Jaeger. So let's go to Honeycomb. The fun part is I'm sending this data to our sandbox team. Hello, Otter. So if you go to jessitron.com/honeycomb, which is easier to spell, this is a redirect to our sandbox environment where you can't get to all of Honeycomb here, but you can run queries and you can look at traces. So here is whatever the heck data is in here. I'm going to click on one of these trace IDs, this last one, and then I get a trace. Okay, what I want to see is that command. And then now we can see this took us 4 minutes and most of that was in the session. Okay, here we go. Here's a view command for the file editor and here's a shell command. Here we go. On the shell commands, it gets more interesting. So now we're doing a curl and then another curl. And then we're curling and curling and curling. And how many of these did it actually use? Well, we know it used 4 of them and it did more curls than that. How many curls did it do? Well, it sends, oh yeah, we didn't look at this. When one of these LLM requests, let me find an LLM request in here. Show me the name. LLM request. There we go. So if I look at one of these in here, here's all the fields. Okay, so we can see that this is one in the middle. We looked at the first LLM request last time and we saw the system prompt, which is this. And then it gets what I asked it to do. And then these are out of order because 10 comes after 1. But what it's getting back is, oh, that's interesting. We even give it like the output of the curl. Oh, it didn't do curl-s for silence. So it gets the output of all its curls, which I guess it's where it's noticing small files. Don't know where I got 29 bytes out of that, but okay. And so every tool call that it makes, the next time we talk to it, we send the system prompt, what the user said, the other system prompt, the tool call that it made, the results of that tool call, the next tool call, the next result, the next tool call, the next result. This is all accumulating, and all of this gets sent to the LLM, and along with the function descriptions and everything every time. So it gets to be a lot after a while. What did it come back with? Good. I got a decent image for the capybara, and time for more tool calls, more curl. All right. If anybody finds anything interesting. More animals. Yeah, the quokka and the quagga. If the quagga is it, I wonder if the quagga and the quokka are related at all. But I'm not going to look it up. Don't do it, Jess. Don't get distracted. Okay. So we were looking at this trace, and we were able to see the commands, and we saw a bunch of curls. It happens that I can ask it, command, give me, oh, here, I've got a calculated field that, not the search, calculated field that will tell me exactly how many of each command. So this formula, I'll show you the formula real quick for traceability. Come here, show me the formula. Okay. That's interesting. In the sandbox environment, it won't show me the formula. Check this out. Control C. This won't work for you, but I want to show you the formula. And I'm logged in. I've made this calculated field that, what did that just do? I'm clicking on something wrong. Okay, whatever. I'll look it up later. There's a formula that pulls out just the bash command. So I can see that we did 20 curls, 8 LSs, 6 views. That's actually the string editor. If I put the tool call name in here too. In Honeycomb, group by means show me the values. And what I do a lot of in Honeycomb is, yeah, so there's bash ls. These are some other span. What I do a lot of in Honeycomb is aggregating over the spans in a trace or in multiple traces. This is a big difference between Jaeger, which is specific to distributed tracing, and a tool like Honeycomb, which is observability, so wider than that. We can get the aggregates as well as look at the events. And we could look at them as logs. You can add fields here and see stuff like a log, or we can look at them as aggregates. Okay. That's that story. What matters now is we're doing these. Oh, now we have 10 curls. Okay. Some of them are duplicated, and we can see that that's not useful. Oh, and a W get. But when we look at this experience, when we dig in and we see what it's trying to do and what it's failing to do and the results, we know that this isn't working. What we need to do is give it another tool. This is the fun part. So conveniently, I have all ready to implement another tool. All right, here's the code change that we want to make. We want to add a new tool. But for observability-driven development, the first thing to ask is, for any given trace, what do we expect to be different? And what I expect to be different after adding this image search tool is fewer curls. It should still be doing some curls or wgets, either one, but it should not be doing 20. I want it to do like 4 for 4 animals. So I expect them to be successful and fewer. I expect to see our tool execute as part of the trace. So I expect to see a difference in here, fewer curls, more web search. And I expect to see the success. And the other thing that I want is in this trace, we are going to be able to see useful, whether it was useful. There's a field on here that says, no, it was a waste. I want to see that change. All right, so now I'm going to make the code change. Why are you underlined? That's not good. Okay. Hopefully that was the right import. Let's run it again and see if we get a difference. Now, in this case, I'm testing it, right? This is local development and I'm testing it, but notice that I'm still using the observability in this test. Now, generally in local development, log statements work because if you're just reading the logs, if I just have logs turned on and, oh, there's my prompt. What do I want to build? Oh, please. Okay, I'm doing something weird with the command line. Please add cool animals like quaggas and otters and capybaras, or a quokka if you can't find a quagga. I think it got that. Oh, I missed the Q. It'll probably figure that out. All right, let's see if it does. Okay, so in local development, you know, if I have some logging that says whether it used the web search tool, if I just log the output or the tool calls that it makes, that's going to be enough for me to tell whether it works. But that doesn't scale to production. It doesn't scale to dozens or hundreds of people using the software at the same time, where those log statements get all mixed up. If you use a request ID that you pass through, and so all the logs for one request have the same request ID, that helps. You can get them in time order. And in this case, these traces are, where'd my trace go? These traces are pretty time ordered, and that would work because there's not a lot of asynchronous stuff happening. The stuff that's happening at the same time is, well, these are the same stuffs. But when you have a proper distributed trace, like that GraphQL server is going to fire off a bunch of queries at the same time, the temporal order of something doesn't express the causality of it. That's where having a trace ID, which functions as a request ID, and the parent span structure that lets it build a tree makes the traces superior to logs. And what that does is it scales up, because you can always get, for any request, you can get a whole picture of exactly what happened for that one. It's not jumbled with everything else. It's not even jumbled with itself when things are happening in parallel in multiple services. So when I start with observability, instead of just satisfying for, oh, well, it worked on my box, I could tell that it was working. No, I want to be able to tell that it was working in production. This is observability as the power we give ourselves to understand what's happening in our software. Right, so I start from here because I know this is going to scale. And I want to see if it's happy yet. I want to see a difference in the trace for this one. Oh, I got to tell it to go. All right, so now it is, oh, it's checking whether we already have any quokkas. That's reasonable. And now it's doing web search. Great. Quokka, cute, smiling animal. I don't know, a smiling quokka might be kind of creepy. Well, we'll see what it comes up with. Okay, so it was step one, what do we want to see difference in a trace? Step two, try the code change locally. But there's more to think about, because that being able to see it in a trace is going to tell me that it's working, and it's going to help me. It's going to help me if there's a bug, right? If like my web search tool and some other piece of the program are not compatible, I'm going to be able to see that in the trace, and I'm going to be able to see the errors. Oh, we haven't seen any error spans. I don't think we've hit any errors yet, but we'll see in a minute. cool. All the animals are ready to be viewed in your carousel. Let's see whether that's working. Where's our simple web page? Here. Control-Shift-R. I don't want to see any more cheetahs unless it's labeled as a cheetah. Tuba, magic card, cat, otter. Otter still. It didn't work. Oh, wait. Okay, it just updated. That might be a quokka. Is a quokka a zebra? Oh, you know what? Oh, I forgot to roll back. That's okay. So we kept the pictures that it already had. All right, now, and so that's one it already had, but it added this happy quokka, which is maybe legitimately a quokka. All right. Now I'm going to demonstrate how I do AI development. Okay, first of all, I'm not sure whether that was useful or not. I'm going to go to my simple web page. And what I forgot to do is roll back the broken change. And then I did this other change in the wrong order. And what I do when I find out I did things in the wrong order, I mean, this is AI. It's not my code. I throw it away. And I'm like, okay, let's just do it again, but in a different order. So I'll start it up again and we'll see if we get some better output. But in the meantime, we can still go look at the trace and see what went on. No stupid shell aliases. Do you remember what I said last time? No. Add some great animals. Quaggas or quokkas, if you can't find those. Otters, capybaras, etc. All right. So while that's working, we'll go look at the other trace. Okay. Yeah. With AI, it's like throw the code away. Just throw it away. Do not feel like whatever slop it outputs is something you need to hold on to. I'm going to go back to Honeycomb and clear everything. So here's a flat query. Oh, it should be, let's do last 10 minutes. Run query. All right, that's everything. And here's the easiest way to get to a trace in Honeycomb. Click on a graph, save view trace. But that's going to be the current one. I want this one from a few minutes ago. Click on the graph, save view trace. All right. Now we're in here. Let's make sure it's the one I wanted. Yes, animals like quaggas. This is the one where I misspelled quagga. And let's look at the commands that it ran. First of all, let's see. There's a view. Let's see how many curls were in there. I don't see any curls. wget? Okay. Yes, we have some wgets. It's not actually 18 of them. It's just that everything after we did one includes that text. So let's I want to know how many of each command we had again. And I just deleted that query. And I can't get to the history. I would get to the history. Actually, here we go. This, but with a different trace ID. Did I lose the trace ID? Here it is. Okay, so here's our new trace ID. Copy this, and this is the query that I want, except this one, not this one. All right, so new trace, same query. Different time range. All right. Okay, how many curls do we have? None, but we have one wget. I guess that's that quokka. It did add one good quokka, but it was fooled into thinking that the other animal images were right. So that's successful. And here's our web image search right here. So that's great. It's the purple one. If I view trace from there, I'll get that span in particular. Yes, here's our execute web search. And here's what came out of it. That's successful. Probably it has six. Oh, man. Oh, it looks like, did it do the thing already? It added some animals. It added at least one animal. So we should be able to check it. But what matters is not, right. So this doesn't have the carousel stuff. I should have committed after the carousel stuff because I did like that. No, what is this? That is a zebra. So I didn't do get clean, did I? It found the quokka. It found the otter. It still thinks that's a capybara. Well, live demos, what do you do? I didn't get clean and remove the untracked files. So once again, it thinks that these are legit. But at least the quokka is good. Oh, well. It tried. It really tried. I want to show more about how we would show the value of this code. Man, it just, my fault. I didn't clean it up. We don't have time for me to go back and do it again. Don't do it, Jess. When your demo fails, suck it up and move on. Okay. But we see the trace, and we see at an individual level that this is happening. But I want to know, like, once I deploy this is enough for me to deploy. Like, I can see that it's happening, and I know that I'm going to be able to count it because I can run a query for execute web search. And I should be able to see how many times this happened. Let's do last 2 hours, probably just twice here. What do I have? I have a heat map. No, I want to count. Just once in the last 2 hours? Oh, it didn't even do a web search because it thought it had all the animals it needed. Dang. Replace all those animals with new animals. There, keep it busy. So we see that we had one web search, but it's important that we be able to count this and that we be able to count it in production. So question for the room, when you have, what tool do you use for production debugging? And in particular, I'm curious whether you use the same tools for production debugging as for measuring application performance. And then there's a third thing, which is tracking user actions. And do you use specialized tools for that? Or is it the same tool that you can use for application performance and debugging? Because whatever observability tool you use, it's fantastic if you can use the same one for all three. I mean, sometimes you're going to like want to know what hotspots exist on your web page, and that's specialized. And we use Amplitude, and I think we also have Full Story. So we have specialized tools for user actions in various clients. But if you have observability that was implemented for troubleshooting during incidents, that's usually the killer, like it's the compelling use case for the people with the money. But when you have that, you can also use it to measure application performance, like how slow are things, how many times is it running, and you can use it to track what your users are doing. Because your software can, I mean, you can use it to spy on your users in the sense that whatever interactions they have with the software can record. So now I'm going to switch. This sandbox environment will let you run queries. And you can see lots of things in there, but I want to use a board, and this environment, this public one, doesn't support boards. Because what I want to say is when you're tracking what people are doing with your software and whether the changes that you've made are useful, I recommend creating a dashboard for that. Like here's one about tool calls. And we can see our tool calls in here. Let me switch it to the last 7 days. That'll be everything. We can see everything that went on in everyone who used Open Hands, which this is a demo. It's just me, but I used it on various different projects. I can see that the median number of tool calls is 35 in a session. That's a lot. The most popular one in Bash is grep, but curl is here at 51, and we would like to remove some of those. And I can see which tool calls are used. So Bash is the most popular, and then string replace. Aha, but we have people using web image search. Okay, it's past me. I used web image search in various tests, but when you come back to this board, you implement something, you test it in production, like deliberately, and then you can see one of these. But the interesting part is to come back a few days, a week, a month, a quarter later, and be like, how much impact did my code have? And if you have the right attributes or spans or log statements, and you can aggregate your log statements, that works too. Yeah, Taylor says it would be very cool to see what MCPs his coworkers are using. Exactly. What tools are people using? Then you can build a board like this, and we do this all the time at Honeycomb. You can say, how much impact is this having? And you can say, how much is it costing sometimes if you're in the cloud. The execute file editor has errors. Grep is the most common, which makes you wonder, what if we had a custom tool for that? Would it be more efficient? Because every one of these tool calls has a cost associated with it. This cost is calculated from the number of tokens used. So string replace editor across all calls to it has cost us about $22. Any of those we could skip by making a tool call more efficient. Would, like, you can do more in one tool call, would make the costs less. Also, you know what? There's two costs here. The measurable one of financial cost is the tokens, but also there's like people waiting. How long did these cost? Or how long did people wait for these tool calls in aggregate? And we can see that's milliseconds, so 2,000 seconds. And I could be like, 2,000 seconds. How many like minutes is that? Duration milliseconds, but in minutes. CF dot duration minutes. Yeah, it looks plausible. So let's just sum that. That'll be more readable. Sum. So our developers waited a total of like 34 minutes for these string replaces. We'd have to get more granular than this probably to figure out how to make that more efficient. But this is a place that we could improve, saving money and people's times, and then increasing satisfaction. Speaking of satisfaction, more than the web search tool call is used, what we really care about is, let's look at a different board, is whether people like it. So here I'm looking at the LLM costs. I have managed to spend almost $80 in Honeycomb's Anthropic tokens over the last week on Open Hands in particular. But here, some of that was useful. Yes, it made my work easier. It was $36. And some of it was not. No, it doesn't work. This has yet to be seen. Okay, that might have been useful. I pick that whenever, like, I just haven't tested it yet. And no, it was a waste. Okay, $10 was definitely wasted. And there was a time before that question existed in the app or was on the root span anyway. So we can look at their useful choice to find out. And what we really want to see is that useful choice changing over time. Be on a chart, be on a line chart. There. So we want to see more of this and less of this. And we can look for that. So we can add, give me a count. I want to see the count of of useful ones going up. And I can change the granularity to like a day. That would be more meaningful. Okay, here's our count. That's generally upward, right? But, oh, and no, it was a waste has been going down. So that's useful. All right, so observability. Look at your traces beforehand and say what's going to be different, because if you make the traces different, then you can look at it in production. You can find out whether people are using it. And sometimes you can even put a dollar amount or a time amount on how useful it was. Questions on that? And I mean, please put questions in the chat in general. In the meantime, I'm gonna move into how this was implemented. And if we could run the next poll. The next poll is about open telemetry, because open telemetry, I'll go to the website, opentelemetry.io. This is the modern standard for implementing observability. It makes it easier. What this is, among other things, a set of libraries to emit the data that forms into traces, or you can stick with structured logs. There's also metrics. I like to get my metrics from my traces whenever possible, because then you can always drill in and get deeper. But you can do metrics when you want to. And the thing about open telemetry is it provides standardized formats for that data. And that means you can send it to any open telemetry data. So I'm sending the same data to Jaeger and to Honeycomb, and you can send it to New Relic and Grafana and Datadog and whoever. They all accept open telemetry formats to varying degrees of usefulness. And when you're using open telemetry, you can choose your observability vendor later. You can send it to multiple. You can switch. So that's like the top recommendation. Although if you can also send structured logs and do aggregations over them, and then you're getting observability too. Right. And the way that works is, I'll show you in this particular, it's different per language, but I'll show you in this app. A pangolin and an axolotl. Okay, now I have to look. Ooh, a pangolin, the world's only scaly mammal. Wow. I guess armadillos aren't scaly. They're just hard shelled. A fennec fox. We've got an axolotl. That is really cute. And a panda. Fabulous. Okay, that was a good result. Good job, Open Hands. You did it that time. You used real web search. Yes, and that was a good one. When I'm running this, I'm running it with Control-J, this script. And here's the killer part. This is Python. The way you do this in Python is you install some packages and you stick OpenTelemetry instrument in front of Python. There's a different command line argument for Java or for Node. Each implementation is customized to the language, but roughly you don't have to do much to start getting traces. The other thing you have to do is tell it where to send them, and which is these environment variables. And I'm sending them to localhost. I'm running an OpenTelemetry collector. That's a different topic, but that's how I'm sending them to 2 places at once. 3 really. So that's useful, but it's some environment variables and a wrapper for the basics. Now, let's see which ones we get with the basics. If I group this stuff by library name, don't care about duration, I'll see what was automatic instrumentation and what was custom. Okay, these ones with open hands in it, these are custom instrumentation that I created. Light LLM, library, OpenTelemetry instrumentation Jinja 2, library. So that just happened. with some installations. And then there's a lot of custom instrumentation in this one because it's a command line client. If you have a web server, I mean, what do you want to do? You want to track incoming requests? You want to track outgoing HTTP requests? There's some of that in here too. Those post spans are definitely from this automatic instrumentation. But in a CLI client, there's not that obvious flow of when a library should instrument or not. So I did some stuff myself. And I did a lot of stuff myself in this one because I'm really interested in figuring out how it works. This is the basics. OpenTelemetry defines an API. So this is all open source code. Everything that I install in here is open source. And this is a method that if you don't wrap it with OpenTelemetry instrument, will do nothing. And if you do, it constructs a span, and then you can set whatever attributes you want. One benefit about tracing over just structured logging is when you make a structured log, you have to accumulate all the information and put it all in one log statement. But I created this span here, and if I do a control F on set attributes, oh, there I'm creating a span and setting them immediately. But you don't have to set attributes on a span right after you create it or right when you end it. You can pull let me get current span. You can pull the current span out of thin air, out of global space. OpenTelemetry tracks it for you and set attributes on it. So that's how we can get a lot more information on each span than you can get on a single structured log usually. So that's a major benefit of tracing. But OpenTelemetry, you can make your own spans. You can set attributes on your own spans. You can add events. Like I would love to have an event for how long it takes to start up. I don't have time to demo that. But a nice thing that you can do actually is another reason that observability is more accessible than ever is because you often do need to add code. If you're running it like a web server, you probably don't even need to create any spans of your own. You do need to set attributes. Always set who is using this, what team are they on, or what account when it's a SaaS, and what are they trying to do? So you do want to set custom attributes, but now we have the AI to do that. So it's fun to run OpenHands on itself. Takes a little longer, but it can be done to add what I want. What I love about software is that it is a socio-technical system, and it's a learning system. It involves the developers, the code, sometimes the users. And the code learns from the developers because we change it. And we as developers are learning from the code because, among other things, observability, also tests, also error messages, also what it changed in the database. But observability is the clearest. It's the power that we give ourselves. We deliberately get the code to tell us what's going on and give us the clearest messages. And what's going on includes the users. So whenever the users are interrelating with the software, we can measure that and find it out. For instance, check this out. If I look for what we're asking people, the questions, and what they chose, only where a question exists, please, I can find out whether this prompt, this setup shell aliases, I don't know who added that feature. Someone on my team thought this would be useful to people. I don't like it. So I'm going to go back to the data and I'm going to find out how often do people say yes to that. Run query. Okay. Set up shell aliases. No, skip this step. 6. Well, let me expand that to forever. No, skip this step. 40. How many people have said yes? 0. No one has ever said yes to that question. Can we please take it out? If you really want to make it available, add a like dash set up shell aliases or something, but get that out of my face. In fact, I wonder if I could sum the duration. Did I save the minutes? I did not. I should have saved that calculated field. This is how many milliseconds people have lost to that dumb question. All right. So you can get some nice data-driven prioritization sometimes. And my favorite thing, you can figure out what code to delete. When we add code like this set attribute, this code is called instrumentation. And it's called instrumentation because the word comes out of like science, like rocket science. If you send a missile up into the air, you know how fast it's going, not because you're measuring it from outside, but because it transmits that information down. So that information is called telemetry. All of the traces, logs, and metrics are telemetry because they exist for us to learn from as developers. And the code that causes that telemetry to come out is called instrumentation, like a scientific instrument, like a thermometer. We couldn't learn nearly as much about heat transfer and weather until we had a thermometer and a barometer and tools like that. Scientific instruments like determine where our limits are in science. And instrumentation determines our limits in knowing what's happening in production for troubleshooting, for measuring app performance, and for seeing what our users are doing and what's valuable. And I'm going to stop share. Do we have any more questions? Oh, the overhead cost of adding tracking. That's a good question. It can be measured and has. If you are doing stock trading and nanoseconds matter, this is not the tracking for you. If you are doing web requests and milliseconds matter, this is fine because it's going to be in nanoseconds. There are extra tricks you can do with like batch sizes, with running a collector locally to offload some of the exporting and processing if you want. There are optimizations you can make if you care about nanoseconds. But generally for user-facing software, it's low. I missed the poll answer. Dang it. Was the poll multiple choice? I wanted the poll to be select more than one. Oh, thanks. Yeah, I definitely wanted that to be select more than one. And automatic instrumentation is those libraries that OpenTelemetry provides so that you don't have to create the spans, it just does it for you. Great, thank you everyone. We're at time and I hope you learned something. Let us know how it went. I'm online at jessatron.com or jessatron@honeycomb.io. There are a few references in some slides that are in the resources section and will be sent to you. And I'd love to hear from you.